Hey, how's
Hi,
it going?
good. How are you?
Doing good.
Good. I have been going crazy on this lesson 11 now.
Really?
I just took the homework test. I failed it. I missed every one,
Oh, it can be hard, yeah.
every single one of them.
It's difficult. So, but I think we just start with the first one. Um, so I don't know how we're supposed to. I've already done lesson 8
Okay,
because I thought we were just supposed I thought it was a review assignment. So I don't know if we just want to do it on our own because it's kind of like a pre-test before the actual test.
that's this one.
Hold on. I think so, yeah. Where you go through it. I already did that. I did the group quiz too because I thought it was a pre-test.
But all you do is put this stuff in there, right?
I think so, yeah.
Okay, so did you do good
So
on it?
yeah, I did all right, yeah. So
Okay, so
it's long because it's just as long as the test.
yeah, it
So
is long. I had all filled out and everything, but I didn't put any of it in because I didn't know if we were supposed to.
yeah, I think it just kind of walks you through it. So
Okay,
and
I'll
then
put
that
that in.
he did that group thing on YouTube. Did you watch that?
I didn't watch it. No.
No, so yeah, he recorded it. You can watch it again, and that kind of helps you out like with any questions and stuff.
Okay.
It's kind of just like all the other quizzes we've done, just wrapped into one.
Okay.
So I think we can just start on the group quiz for lesson 9.
Yeah, this has been a tough unit already, I think.
Yeah, this one's a little bit more difficult than last time.
All right, so let's go to the group meeting. Lesson 9, right?
Yes.
That's the null one, right?
Yeah, null is where it equals each other. Okay.
Yeah, the null is true unless enough evidence proves it's not.
Yep. Okay, suppose the null hypothesis equals 10. U equals 10. Use this information to answer the next 3 questions. Oh, it doesn't equal 10, right? That's the two-sided.
Yeah, that's the third one down, right?
Yeah, where it's like does not equal 10. And then the left-tailed test is the greater than the first one.
Okay, yeah.
And then the right-tailed should be less than. Or should go this way and then this way.
Yeah, it should be the bigger eating the number and then the other way, yeah, on the right side.
Yeah.
And then, right?
Yeah, so it should be facing the number for left and then facing the U for the right. Yep.
I know it's hard to do that greater than less
Yeah,
than.
you gotta think, okay, left is this, left is right. Okay, remember that we determine the outcome of a hypothesis test by comparing the P. p-value to the level of significance or alpha. Use this information to answer which would result in failing to reject the null hypothesis. Oh, I can't remember these letters.
The p-value has to be less than in order for it to be rejected. Is that what we're saying?
Yeah, so the p-value needs to be lower than, but it doesn't need to.
It's failing to reject. So failing to reject would be the greater than, right? Isn't that opposite of it?
I think so, yeah.
So if the value is greater than A.
So the p-value is greater than A?
Because I got, that's the way, so the first, right? Because it says which relationship would result in failing to reject the null. So I got, you have to reject the null.
Failing, okay, yeah.
So it's the first one, right?
Yes, that's, okay. Yeah. Because I guess the failing to reject the double negative was throwing me off.
Wording on it, but I know it says to reject the null if it's less than, so we're not doing that. So
yeah, so that would be the next one. So to reject it, the p-value is going to be less than alpha.
Yeah.
Okay. Okay, an insurance company is reviewing its current policy rates. When they originally set up the rates, it was about 15,000. They are concerned that the true mean is actually higher than this. Which of the following would be the appropriate alternative hypothesis? So they're saying it's greater.
So they're saying the third one, average claim amount is going to be greater. Right?
Yeah. Good. Yeah, that's what they're saying. But isn't the alternative the opposite of the null?
Yeah.
So if they're saying that it's 1,500, wouldn't it be the average claim is less than 15?
Yeah, maybe.
Because that's what I'm thinking. It's like they're saying it's this, so that would be U equals 1,500. And then they're saying it's actually higher. So the alternative of that would be the opposite.
But if you were writing that out, you would write the HO equals the 1,500. And then you'd write the next one, because they're talking about being higher. Wouldn't you write that as the HA is greater than 1,500?
Yeah, that is true. Yeah.
Right?
Yeah, that could be it.
There's no numbers to compute it, but that's how you would write it, right?
Yeah, but I'm thinking that's the null hypothesis. Because the null hypothesis is saying that it's greater, and then the alternative would be the opposite of the null.
See, this is one of the examples. It says the mean price of a single family home is 300,000. A real estate agent says that the price would decrease since then. So when they write it out, they write HO is equal to the 300,000. The HA is less than the 300,000 because they said it would decrease.
Okay, that makes sense. So it's greater than?
I think it is.
Okay, so what would be the null hypothesis then?
I think so. Hope I didn't get that one wrong. Sorry if I did.
No, it's not a problem. No matter what, we get a second chance, so which is always good.
That's right. So this one is saying it's equal to.
Okay, that's what I was thinking. Yeah.
Okay. We have to work out, right?
Well, the assumptions are confusing.
I know. Sample size is large. Distribution of sample means is normal. Okay, it is normal because it's a large sample size.
Yeah, that's what I was thinking. It has to be. So it's a good assumption because the sample size is large.
That's the theorem. That's law of large numbers, right?
Huh? What was that?
That's the law of large numbers, right?
Yeah, that was from last time. Yep, the law of large numbers. Ooh, which of the following is the test statistic?
That's the x.
Is it X?
Find the z.
Is it X? You said?
I think it's we're finding the z. I don't know which one it is because it says it uses all of them. The test statistic and the p-value will be illustrated. I'm thinking it's z because I have compute the test statistic.
Yeah, I'm thinking it's Z. At first I was thinking it was U, but U's not an answer.
Right.
So it's got to be Z, yeah.
I think that's the sample. I think we're trying to find that z.
Yeah.
Historical means.
Oh, the Z score. How do we do that again? Go back to my other notes. Do you remember how to get the Z score?
Yes, yeah, Scott. Yeah.
What was that? The equation?
Yeah, standard deviation divided by the sample n, but I don't see the sample n on there. So I think it's just I have or just okay, that is gonna be x minus the u over the zero. So that's that.
So it's 144 minus 150.
Minus the
Then you divide that by the 0.05, right?
150 divided by the standard deviation.
Oh, I say at 40. So it's 0.1.
0.1.
No, because it's going to be 144 minus 150, and then you divide that by 40. 0.15. It says to 3 decimal places. It says that for all of them, so. The p-value.
This actually is different than what we did here on this thing. Let's see. Yeah, that don't have an n value. So yeah, that would have to wait. What's the 36? That's what you divided by the square root of 36.
You divide by, oh, yeah, that's where you have to times it. Okay, so it's going to be, 6. And then don't you do 40 divided by 6?
40 divided by
and then
30.
Yeah, and then 6 divided by that. 0.9? I don't know if that's right either, though.
I have negative 40.
You got negative 40?
Right?
I didn't get that. Let me find that equation.
Point -9.
Yeah, that's what I got. Yeah, because you do the x minus the u. So the x is 144 minus the u, which is 150. So that's going to be -6. And then you do -6 of sigma, which is the standard deviation, divided by, so sigma is 40 divided by the square root of 36. Then you do 6 divided by that. Yeah, not -0.9. That's got to be it. P-value. Then what's the p-value?
That's what you type it in. You type negative, and that's greater.
What was that?
We're looking for. We're going to do the left side. Is that right? Which side? Yeah, left side.
The left side of it?
The left side.
So everything below the middle.
Is it below the middle or just the left side?
Let's see, because it's equal and greater than, so we do. Yeah, it's just below the first blue line. So 0.184.
Okay, so then we said if it was less than the significant, then you reject it.
Yeah, so that's.
Then no, it's not. It's greater than.
Yeah, so we're going to fail to reject, right?
So if we fail, then we don't have.
If P is low, reject the null.
We do not have insufficient evidence.
So yeah, it's P is greater than alpha. What's the alpha? 0.05. So we actually are going to. We failed to reject it because the P is greater.
So then that's because we have insufficient evidence that the true population mean is 150.
Yeah.
Or is it says we were looking for the population to be less than 150.
Yeah.
Would be the third one down, right?
Yeah, we have that it's not less than 150 because it probably is more. The two types of errors that can be made when performing it, which one involves rejecting? Oh, which one? What's the difference between type 1 and type 2? Okay, type 1 is the null is true.
Yeah. Because the second one, alternate.
Fail to reject. Yeah, so it's the second one that.
So type 1, right?
Which one? Oh, which one involves rejecting? Yeah, type 1.
Okay.
20.
So that would be the third one down. Probably the null would be true at that point because it would, instead of 0.5, it would be greater.
Yeah,
right?
it'd be way greater. So yeah. No, wait, no. Yeah, because there's a less likelihood that it's true. Yeah. Like, because now you're, instead of only 50% away, like 2 times higher, you're now 100 times higher.
Reject.
What was that?
Right?
You keep cutting out. I can't hear you. I don't know what you're saying.
Sticking with number 3 on that.
Yeah, number 3. Yeah. Oh, I don't know how to come. Oh. I don't know how to do that.
Let me look on the test and see if we turn it on.
I think it's just 50%.
I think it's 50%.
I think so.
Can you type that in? Type that in the applet. Will it give you something?
No, because that's an alpha. I guess it could be the area, maybe. And see, it's still gonna. It's just. It says a level of significance of 0.05 seems a strike balance between the probabilities of committing a type 1 and versus a type 2. However, it means just blah blah blah. This is equal to 1/20, which is, I guess, 5%. So I'm gonna put 5%, 5.0, and then I'll submit it, and we'll see what we did. I don't think that last one's right. Okay. Okay, so we got the last one wrong. Well, no, we got it right, but how you have to put it in is 0.0500.
So you put 0.0500.
Yeah, and then number 20 is the probability of a type 2 error will increase. And then we missed, I think, 2 more.
Type 1.
The probability of type 2 will increase.
That's 20.
That was 20, yeah. And then on question 15, you have to put negative 0.900. I didn't put the 2 zeros at the end. And I think there's one more. Oh, and then 13 is central limit.
Okay.
Okay, I'm just redoing it real fast. All right, I'm ready to start number test 10. What was that?
Because I've already taken homework quiz 10.
You've already taken homework quiz 10? Or group quiz?
Oh, sorry. Maybe I went the wrong one. Sorry.
No, you're fine. I was gonna say, well, you can walk me through it.
I was like, how did I do that one? I'm in the right spot now. Here we go.
All right, this one's shorter. This one's only 14. That's nice.
Yeah, it is nice.
Margin of error. Where's that equation again?
Find that. These are always hard.
Yeah, there's a big problem.
For the 50%, you use the 1.65. So 645.
645. 0.645.
1.645. And then you multiply it by your standard deviation, which is the 50 over the standard of 25. Square root of the standard.
So you times it by 50.
You're going to do 1.64 times 50 divided by the square root of 25.
The square root of 25. So you should get 1.645.
I think I second again. I got 15.45. I don't think that's right.
Okay, so oh, that's why. So you're gonna do x, which is, what is x?
X is the 90% thing. So that's that 1.645.
That's z.
That is Z.
Yeah, that's z. So what is x? X is point estimate.
Well, I have the problem wrote down. It's the 95%. It's out there. And then I have the standard deviation divided by this and standard. I'm thinking, 16. Let me see. 645. Find the margin of error.
I got 16.5.
16.45?
Yeah.
That's what I got, but it seems awful big.
Yeah, but the population size is only 25. So, and there's a standard deviation of 50, so that's pretty big.
The x with the line is
What was that?
one is estimator, an interval estimate. I don't know what that one is. And then the U or is that's anything about the only thing it does is have that X with line over it. And I have it on here, X with line over it says sample mean the point estimate.
Yeah, that makes sense. So you're doing the second one?
So it's the only thing I have that fits in there.
Yeah. Makes sense with me. Yeah, because the first one and the fourth one, I have no idea what those are. So,
Ah.
so sounds good.
Okay. Oh, that's right.
I don't know how to get the point estimate because the point estimate is X with the line over it, but I don't know how to get that. Oh, that's
But maybe that's the same thing. Maybe that Z point estimate equals the margin of error. So maybe that's that thing the Z times the same thing we just did on the last one.
yeah, that would make sense. So what was the version? Z times sigma over square root of n. So it's 113 divided by 8 and times that by 526. I just can't see that right.
Okay, so 1,
That's so big.
2, 6, 1, 3, 4, 4.
Because did you get like 7,000?
61.25.
What'd you get? 6.125?
Yeah, no. Yeah,
What'd you get?
61.25, well, 26 actually.
61.25.
80.
Okay, that sounds good. I don't know how to do that.
What do you think again? Just a second. That just can't be. That just doesn't look right. I just can't think that's it.
Yeah, I don't.
That's too many numbers, I think.
Oh, I know. Okay, I know what I did wrong.
What'd you do?
Um, It's 489 or 498.32.
498.32.
32, yeah.
That's a big number.
Yeah. Um, yeah. That's what the equation shows. So,
So what did you do?
so I did alpha, the little sigma, so it's like the circle. That's 113. So I did 113 divided by the square root of 64 times 1.96 because it's a 95% confidence interval, and then did 526 minus the answer I got from that.
And that's where you got 498.
Yeah. Unless,
I don't see any of that in here. It's like,
yeah, it's if you go to the book, like the online book, that's where I found it. It's under putting it all together, confidence intervals for you when alpha is known. But yeah, it's got to be it. No, I don't. It's got to be just five. I bet you it's 526.
you know what?
It's got to be 526.
What does?
Number 5.
Number 5 has got to be 526?
Yeah, because then the lower end is what I just had, and then the higher end I add it instead of subtract. Yeah, okay. I'm pretty sure. Because then the 95th one and then number 6, you would do 113 divided by the square root of 64 times 1.96, 27.685.
I'm completely lost.
Yeah, I'm gonna run through this. Let's after because what I think you have to do, because the point estimate, what it's saying is x with the line over the top, and that's what the point estimate is, and there's no way to solve for it. So I'm guessing they just gave it to us, and then you find the same as what they gave us. Yeah, 526.
Okay.
And then to find the margin of error, you do the z, which is the given for 95%, which is 1.96, and then you times that by sigma, or 113 divided by square root of 64. And then that's the margin of error. And then the lower limit is 526 minus the margin of error. And then the upper limit is the 526 plus the margin of error.
Okay. So what did you get on 6 then?
27.685.
27.68. Right?
Yeah, and then for 7, I got 498.315. What we had before for number 5.
498.315.
Yeah. Plus. And then for the next one, I got 553.685. I'm guessing that's.
I see the intervals on this thing here where you take the z times the thing like what you're saying, yeah.
Yeah, so, and that's what I'm saying. It's got to be that. It's got to be the lower end and then the higher end.
Let me see here.
So, and then I would think number 9, it would be decrease. Because then you're increasing n, which would make what you divide by smaller.
So the last one.
Yeah. That would increase. 10 is increase. See, these are so confusing.
Mm-hmm.
What is M?
I saw this one. I did this one yesterday. This was really hard for me to do because this is I had to Google this. I couldn't find it anywhere.
Yeah, I just found the equation. So it's z times sigma divided by m. But what is m? M equals 2.
I've got.
How do you get m if you don't have n? You're solving for n and you don't. What the heck?
Here, z squared times the standard deviation times the standard deviation margin of error squared. So,
all right. Yeah.
0.96. We're going to square it, and then we're going to multiply the standard deviation twice. So that's a big number, 400. And then we're going to divide it by the 50. Okay, so when we square this one here, we get 3.84 times, and then 400.
You get 246. That's what I got. Okay.
Are we still using 95%?
What was that?
95% number?
For which one? Number 12?
Oh, no, I guess it is number 12. Yes, number 12.
Yeah, so we do it kind of how we were doing those other ones. So you have to find the confidence intervals. So you have to do Z. So you got to do 1 point. So it's a 95. So it's 1.96 time. Or first do alpha. So it's at 37,000. 36,706 divided by square root of 36. And then you times that by 95 confidence. Then you're going to do 111,000 minus that number. Yep.
I got 53.41.
No, you should get 99,001.
One.
Yeah, so you're gonna do do you have a calculator next to you? Or are you using your phone or
Calculator.
okay, so type in that 36,703 and then divide by 6 because that's the square root of 36 and hit enter. And then times the number you get by 1.96 and then take that number that you get and do a 111,000 minus that number you got.
Oh, 111,000 minus. I still don't
You still don't get it?
get that answer.
You still don't get 99,001.53.
Oh, my first answer?
So you should do 36,730 divided by 6, and you should get 6121.6.
Okay, I got 6.121.
When you did three, so you do 36730 divided by 6.
Okay, that's where the problem is. I'm sorry. 1, 2, 1. Okay. And then I subtract that.
And then you times that by 1.96.
Okay, so now I got 9.
Okay.
And that's the
Yep. So save that 11998.46. Save that number because then you're going to do the exact same thing, but you add it instead of subtract it to 111,000.
I got 992. Did you get 991?
You get 99002.
99002.
Yeah. I just submitted it. It makes you put 99002.000. I don't know why.
That's what huh?
You have to type 99002.000.
Okay.
So yeah, then the next for 13, you do the exact same thing, but you add it instead of subtracting it to 111,000.
And what did you get?
I got 122,998.000.
Okay.
And then 14 is all of the above.
Are you submitting? You want me to?
I already did.
So which one did you miss?
None of them. So I typed in one of them wrong, but I told you I must have dyslexic or something because I typed it in backwards.
My computer froze for a second. Sorry.
No, that's fine.
Then I'm underpaid. Yeah, second. I'm trying to submit it and it kicked me out.
Oh, okay. Well, if you get it pulled back up, I'll just read off the answers to you. If it didn't submit it or save it.
Nope, it deleted all my answers.
Okay. Do you need them again?
Okay, number 3.
16.45. Number 4 is X is a point estimator of U. Number 5 is 526. Number 6.
Wait.
Uh-huh.
Okay, what is it?
Number
5?
526.
526. Nope, dot in there. 526.
Yes, and then number 6 is 27.685.
Okay, number 7
is 498.315.
Okay.
553.685.
Okay.
Number 9 is decreases. Number 10 is increases. Number 11 is 246. Number 12 is 99002.000. Or, yeah. Number 13 is 122,998.000.
Okay.
The number 12, and the last one's all of the above.
Okay, got that one. And the group 11.
Lesson 11.
Got lost on.
Huh?
Failed.
Is this one hard?
All right.
What? In previous lessons, we had assumed that the population standard deviation alpha was known. In this lesson, we were making a different assumption about what has changed, that it's unknown.
I think Yeah, because we always had it beforehand. Now we're saying it's not.
Yeah. Okay. Number 4. No. That was easy. Okay, what is the value of t? Okay, so the equation for t is t equals x minus u divided by s divided by square root of n. So x is 11. So 11 minus u, which is 8. That's 3. 3 divided by, let's do s. What's s? So 6 divided by 9. 3 divided by 2. 1.5. Did you get 1.5?
You get 1.5.
Yeah, that's what I got. Oh, way to use this. Heck, what software?
Little under the Excel, you have to write all down and input them all individually.
So you can copy and paste them, but oh, you can't copy them? Oh, mine won't let them copy them either, huh? No. There's no way. You're kidding me. That'd take forever. Can't think about that. Oh, I guess the body temp file is right here. I can get to it. No, I can't. It didn't let me. Oh man, this is gonna take forever, isn't it? I don't have that much longer to go. I gotta do some. I gotta stuff. I gotta finish.
Yeah.
Let's see what.
That way. Yep. So,
Do you know how to do this?
well, this is where all the input is in the thing, and then it puts it all out there for you.
See, I don't know where that file is. What software? Just Excel?
Yeah, Excel. Please, do you have that Excel whole thing?
Which one?
Well,
the help?
Help. There's a link to the very top. Yeah, that T distribution.
Yeah, so I opened that up, but what?
Does it not look right?
There's no way to put anything in it. Man, this is a lot.
Let me see if I can put all of those in then. I mean, because I can get to my, have the other, it's the called.
See, I just don't know after I type it into Excel what I'm supposed to do after that.
Well, it's not in Excel, it's in one of the other files. It's in the data quantum thing or whatever it's called.
The data files? The body temperature?
Interference 1. It's that one.
See, I don't have that one. What did you?
I downloaded that earlier. And so in the first little box, you have to put all those in. So you read them off to me, and I'll put them in.
Okay.
Let me get to it again. Okay, what's the first one?
98.
98.
99.6.
9.6.
97.
Oh, wait, that didn't get 9 point. You said 99.6.
Yeah. 97.8. 97.6. 98.7. 98.4. 98.9. 97.1. 99.2. 97.4. 99.1. 96.9. 98.8. 99.9. 96.8. 97. 98.
97.
97.
Okay.
98.7. 97.6. 98.7. 98.2.
Point what?
2.
Okay. So we type it all in, and then what's the null?
The null.
Say that.
I do not know.
Let me look if I can. Okay, that's that. That's the 98.6.
Okay. Yeah, I don't have that sheet up, so you're gonna have to read it.
Okay, so
I don't even know where you got that sheet from.
98.6 is the null. Does that say greater than, or is it saying no, just the difference? What does it say?
For which one?
That same one.
That question?
Yeah.
It just says, what is the x? Which would be the x is the, I always forget.
Just a second. I think I had this example on one of these homework pages because like I said, this is the one I couldn't figure out. And it kept, like I said, I failed this test because I couldn't do it.
Yeah, this is getting kind of annoying. Yeah, I found that thing. I'm going to type mine in real fast.
Okay.
See if I can help you.
I don't know if the null would be on that thing. Because it doesn't say if it's greater than or anything. I guess it's like not equal to or.
No.
Oh, no, I think it was equal. It was. Yeah, because it's giving me it's actually less than. What is x?
Okay.
Here. X is the mean. So what does the mean say on there? The mean says 98.2
So you get 98.
98.20.
All right, that's what I got.
So that's in 98.200. 98.2. Okay, so then the S should be in there too.
Which one's the
Deviation.
S? The S is what?
The S is a standard deviation, so that's the 0.922, right? Yes. Yes.
Yeah.
That's 922.
0.922, yeah.
0.922, right?
0.922.
And then the T-score was on there also.
That's 427.9, right?
You got a T-score?
I think that's what it says.
Negative 1.843.
P score or T score?
T as in Tom.
You got what?
1.843.
1.843.
Is that what you got?
That's not what mine says, but I think mine's messed up. So I'll trust yours. That sounds better than mine. What'd you get for the P?
The P I have 0.04048182.
0.0404. So
Eight.
0.040 is 3 decimal places.
Okay. So we got 0.0404. Oh, that's 4. It's only just to the 4. So is that 0.040?
Yeah, 0.040.
And then we compare that to the 0.5.
Compared to 0.5, so it's fail because it's lower.
I thought if it's low, be.
Or it's reject. Yeah. Because last time it was higher and it was fail.
Right.
Okay. All right, so we do the same thing. So let me enter in these numbers, give you these numbers again.
Okay, let me get to it again. I got to delete all those other ones because that's why I found out that's part of the problem was that these all, when I did this last time, those numbers didn't get deleted.
Oh, yeah, that can mess it up.
Okay, what's the numbers?
Okay. 59, 14, okay. 37, 62, 68, 2, 15, 9, 157, 27, 37, 2, 55, 86, 14.
86?
Yes.
86?
Yes. And then 14, 4, 40, 36, 47.
14? Oh, wait. 86, 14?
Yes. And then 4. And then 40. Then 36. Then 47. Then 9.
Then what?
9. Then 61.
Okay. All right. So what's our null hypothesis?
Is equals and then not equals.
So what's the equal one?
40.
What number?
40.
40? Okay, and then it's not equals on the other one.
Yeah.
Okay. Okay. So now.
And then it's what's the p-value?
The p-value is 0.9952.
Okay. 0.995. Okay. And then if that's way higher, so we're going to fail to reject. Okay. Okay. Did you get those two? 11 and 12.
Yes, so 13.
And then 13, so it says if you decide to try another hypothesis, this time you use greater than 40, you keep the same significance. Did your p-value increase or decrease?
So I need to go change it to 40?
Yeah, to less than 40. You change it to like 35.
Or just leave it at 40 and just do less than?
Yeah, or that, yeah.
Okay, so now when I do the p-value with that one goes to 0.5023.
Okay, so it decreased. But we're still going to fail to reject it, right? Because it's 0.5.
Right.
And the significance is 0.01, yes. So it'd have to be below, it'd have to be 0.00 something. Okay. Okay, so now we got to do this. So do you have I'll do this math.
I actually have those.
Oh, you have the lower limits? Oh, that is awesome. At the 95th?
So the lower one is 23.499.
499.
Uh-huh. And the upper
23.5 is just one decimal place.
Oh, okay, so just one, okay.
Yeah.
And then the other one is 56.6.
Sounds good. All right, I'll submit it real fast just to make sure that it was right. Okay. So far, so good. Okay, we missed 8. But that was it. And we only missed 8 because it was supposed to be negative.
It was supposed to be negative?
Yeah, same number, but it's negative.
Okay, we got everything else right?
Yep.
Yay.
Good job. That one was rough.
Failed that on my own.
No, yeah, that was very confusing. So
See if I missed any when I submit it real fast, if you don't mind.
Nope, no problem.
And then I'll go back in on lesson 8 and just put the ones I have on my quick. So all you do is just input it, right?
Yeah, I'm pretty sure it just walks you through it. So hopefully, because that's what I did. I don't remember what I got. I did it a while ago.
Okay, that's it then. So we got everything done for now, right? And we just have to do that unit thing this week. And that's
Yeah,
it,
you just
right?
just have to do the test by Saturday.
Okay, perfect.
So, okay, awesome. I will post this for us.
You want to meet on Tuesday?
Yeah, that Tuesday works.
Same time?
Tuesday night, yeah. Okay, yeah, Tuesday night should work.
Okay.
Okay,
same time.
that works for me. I'll text him this week sometime, tomorrow or Saturday.
Okay,
Okay.
sounds great.
All right, bye.
Bye.